All right, my math friends, here we go. We got lesson 8-4, solving systems by substitution. All right, so we're going to come up with a new method today to solve for the systems problems. It's called the substitution method. So we're going to start off by graphing the system. And remember, the solution to a system is where the two lines intersect each other. So we're looking for the spot where they're going to cross. So the first line has a y-intercept of 3. So I'm going to go up 3 because I'm a good person. There I go. 1, 2, 3. Now over here, there's no number in front of x. That means the slope is 1. So that's 1 over 1. We go up 1 over 1, up 1 over 1, up 1 over 1, and everything is right in the world. There we go. All right, so we have graphed our first line in the system. These are all of the solutions that work for that particular equation. So that's what that line represents. These are all the ordered pairs, the x's and y's that we can plug in here and it works. Second equation has a y-intercept of -2 here, so I'm going to go down 2. And then it has a slope of 2, that's 2 over 1. That means I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or down 2 backwards 1, down 2 backwards 1. All right, so here's my second line. Oh, man. We got a problem here. The answer is where the two lines cross, but with the graph that I was given, these two lines don't show where they cross. I can tell they're going to cross. They're going to cross somewhere over here. I can tell eventually they're going to cross. So what happened when we tried to graph the solution? The graph wasn't big enough to show where the two lines intersect. Let's just say the graph was too small to show the intersection. Now I know that there is going to be an intersection. I just can't see what it is because the graph was too small. So this brings up the first thing that is kind of like a limitation of this graphing system that we were doing all the past week. When we graph it, the graphing system really only works if they intersect somewhere in this small space. But what if the numbers are really big and they're intersecting way up here or way down here or somewhere like that? The graphing system maybe isn't the best system to use all the time. Now it's a nice system so that we can actually see where our solutions are, but it has limitations. So limitation number 1 is it only works when they intersect somewhere on the graph that we're given. So it only works for numbers that are close to 0, 0. I'm going to say only works for numbers close to the origin. So if I'm looking for where two lines cross and it's nowhere close to the origin, the graphing method is not going to be a great method to work. The other thing is, we haven't really seen it, but what if our two lines cross somewhere like right here? I can't tell where that is. Was it 2.2, -3.1? I don't know. So really, our solutions for graphing have been working because we were always crossing at a lattice point. So where it was really easy to see where the solution was. So the graphing method doesn't work very well when the solutions are not whole numbers or integers. Oh, I can spell today. For non-integer solutions. And I'm just going to put it in parentheses here, decimals. It's not going to work really well for decimals. We also saw that it wasn't great to use when it wasn't in slope-intercept form. Remember all those problems that we were doing last week where the equations didn't start in slope-intercept form, and we had to do all that work to get them into slope-intercept form. That's just a lot of extra work. So it only works best for slope-intercept form. All right, so there's limitations to the graphing method. This is not necessarily going to be our go-to method because of all these limitations that we've written down right here. So what we're going to introduce today is something called the substitution method. It's a non-graphing method where we just use algebra to be able to find out where the point is or what's the solution that both of the equations share. So what we're going to do is substitute or replace a value with another value. So in this particular equation, here's what I notice. Y equals x plus 3. So y is equal to x plus 3. But on this equation it says, no, wait. Y could also be x 2x minus 2. So y equals y. Y is the same. So therefore, we can replace y with x plus 3. This equation says, hey, y is x plus 3. So over on this equation, instead of y, by substitution, we can just say, oh, instead of y, I'm going to plug in x plus 3. So we can just write x plus 3. That's what I have replaced y with. I've substituted. This one said y was x plus 3. So on this equation, instead of y, I'm allowed to just plug in x plus 3 because that's what y is equal to. So I have replaced y with x plus 3. So I'm going to rewrite the rest of the equation. So y, which I wrote x plus 3, equals 2x minus 2. Now the great thing about this is I have now eliminated one of my variables. I only have one variable here, which means I can solve this. I can just solve with our normal solving methods that we've done all year. So I've got variables on both sides of the equation, so I would subtract 2x from both sides. Okay, x minus 2x is negative 1x, or just negative x. Over here, 2x and negative 2x cancel each other out, and we're left with negative 2. 2 more steps. Let's subtract 3 from both sides. We're doing our inverse operations. That cancels out the 3 there. Positive 3 and minus 3 is 0. On the other side, negative 2 minus 3 is negative 5. Okay, negative x equals negative 5, but remember this is negative 1x, so negative 1 times x. So to get x truly by itself, I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 is 1, so that just goes away. I get x equals negative 5 divided by negative 1 is 5. Now you have to remember, when we are solving a system, our answer is an ordered pair. I have found the x of that ordered pair. Okay, I still need the y of that ordered pair. Remember, I'm trying to find out where they cross. So this is telling me it's going to cross at 5 something. But 5 what? 5, 7, 5, 8? I don't know. I need to now find what my other value is, what my y value is. I know that x is 5. So what we can do is we can pick either equation and plug in 5 for x. Let's just do this one, it looks easier. So in this equation, I'm going to write y equals, instead of x, we said that x was 5. So let's plug in 5 plus 3. 5 plus 3 is 8. All right, I have my answer. These two lines would have crossed at 5, 8, and that makes sense. Look where 5, 8 would be. Yeah, it looks like those two lines are going to cross up there. So it looks good. Now, the nice thing about doing it algebraically is we can know if we're right by plugging it into the equations and seeing if it works. Now, I know that 5 and 8 works because I just got done plugging it into this equation right here, right? I took y equals 5, so I plugged in 5, and I get y is 8. So let's test this equation. If it works for that equation, we know 100% that we did it correctly. So let's plug it into that other equation over here. Let's check our work. So instead of y, we're going to plug in 8. Instead of x, we're going to plug in 5. So we get 8 equals 10 minus 2. 10 minus 2 is 8. Okay. We got the problem right. So this check, we knew it worked for this equation because we plugged it in there. And now we're checking the second equation. It works for that equation. Therefore, I now know 5, 8 is the answer. So we can know 100% at the end of the problem. All right, let's practice that method a little bit more. Here we go. So over here, I've got x plus 3y equals negative 3, and then x equals negative 2y plus 5. So I know that x is equal to 2y plus 5, negative 2y plus 5. So what I'm allowed to do is substitute. I can take this value and plug it in to the x on the other equation. So I'm taking this value, because x is equal to that, and I'm going to replace this x with that value. Substitute it. It's like a substitute teacher, you know, it's a replacement for your teacher. So we've got, instead of x, we plug negative 2y plus 5. So negative 2y plus 5. So instead of x, I have plugged in negative 2y plus 5. Now let's write the rest of the equation. Plus 3y equals negative 3. All right, we're going to solve this. I have like terms right there. Negative 2y plus 3y, they're on the same side of the equation. So I can just combine those two bad boys together. 3y minus 2y is just 1y. Okay, at this point, I just need to subtract 5 from both sides. I get y is equal to negative 8. Okay, so negative 8 appears to be the y value of my solution. I just need to find the x value. I can plug y into either equation right now, but I think the bottom equation looks easier. So I'm going to do x equals negative 2, and then instead of y, let's plug in negative 8, because we just found out y was negative 8. Plus 5. So I'm taking this equation, and I'm substituting in for y, negative 8, which was the answer I found right here. Okay, so x equals negative 2 times negative 8 is positive 16 plus 5. 16 plus 5 is 21. So it looks like my answer is 21, negative 8. I think that's my answer. I won't know it's my answer until I plug it into this top equation. We just got done using the bottom equation. So let's plug it into the top equation to see if it works. Instead of x, let's plug in 21. Plus 3. Instead of y, let's plug it in negative 8. Equals negative 3. All right, so we've got 21 minus 3 times the negative 8, that's negative 24. 21 minus 24 is negative 3. Aha! Negative 3 does equal negative 3. I now know that this was my answer. Now imagine trying to solve this equation by graphing. 21, 8 would be like way over here and way up here somewhere. You'd have to have a huge graph in order to do that one. So this algebraic method is way better because you don't need to have huge graphs to find every single answer. All right, so we're going to keep on doing the same process. Substitute in, solve a variable. Substitute again, solve the other variable. Then check your answer. If you kind of think that you know what you're doing, give these next two a shot. Pause, and then see how I did it. All right, go ahead and pause it. All right, I'm going to start. Here we go. Okay, so I know that y is equal to negative 2x minus 2. So I'm going to take that and plug it in for this y over here. All right, so I've got 5x plus y. Y is negative 2x plus 2. So I'm going to write negative 2x minus 2 equals negative 20. So remember, this was y right here. I've just replaced it. I've substituted. Okay, so let's go ahead and solve this equation. I'm going to combine like terms. 5x minus 2x is 3x. I'm going to add 2 to both sides, use my addition property of equality. That gives me 3x is equal to negative 18. I'm going to divide by 3, use my division property of equality, and I get x is equal to negative 6. But I know that's not just my answer, that's half my answer. That's the x value of my answer. Now I substitute a second time in order to find out what y is. I think the top equation is the easier one to substitute into. So I write y equals negative 2. X we just said was negative 6. So negative 2 times negative 6 minus 2. All right, so we get y equals negative 2 times negative 6 is positive 12. And then 12 minus 2 ends up being 10. It appears as if my answer is negative 610. Now, I just got done using the top equation, so I know this works for that one. Let's double check to see if it works for the bottom equation. All right, so I'm going to do 5. Instead of x, I plug in negative 6 plus y is 10, equals negative 20. 5 times negative 6 is negative 30. Negative 30 plus 10 is negative 20. Aha, it does work. So I know right now I am 100% correct. You should feel good. All right, last one. Here we go. So for this one, it's a bit of a sticky wicket. I don't have a variable that's by itself. But I can easily get a variable by itself. For instance, I could add 3x to both sides. Or sorry, 3y. I could add 3y to both sides if I was feeling saucy, and I am. So I'm going to add 3y to both sides, and now I've got x equals 3y minus 5. Aha. So I have x isolated. X is equal to 3y minus 5. Let's take that and plug it into this equation right here. So instead of x, we're going to substitute with 3y minus 5. Let's rewrite that top equation. Instead of x, 3y minus 5. Okay, plus 2y equals 15. Now we're going to solve that, combine like terms. 3y plus 2y is 5y. We're going to add 5 to both sides. 5y is equal to 20. We're going to divide by 5 on both sides. Y is equal to 4. So I believe at this point that my y value is 4. Might not be, but that's what I think it is. Okay, now I'm going to plug 4 into one of these two equations. Do not plug it into the one that you created here, because what if you made a mistake? If you made a mistake, of course it's going to come out right. So you always want to substitute back into one of the original equations. I think the top equation looks a bit easier to plug in for. So I'm going to do x plus 2 instead of y. I'm going to plug in 4 equals 15. So x plus 8 equals 15. I'm going to subtract 8 from both sides, and I get x is 7. I think my answer is 7, 4. I don't know for sure until I plugged everything back in. So I just got done using the top equation. So I'm going to plug 7, 4 into the bottom equation. If it works for that, it means I was right. So 7 minus 3, so I plugged in 7 minus 3. Instead of y, I plug in 4. Okay, that's 7 minus 12 equals negative 5. 7 minus 12 is negative 5. Aha! I was right. My answer is 7, 4. And that's the substitution method. Now we have used pretty basic problems. We're going to take it up another notch on the next set of notes. That's all I got for you. Keep math in the heart. Bye-bye.